do, Doctor, and
You're always welcome.
thank you for your presentation as always. So I have two questions. The first is regards to the normalization.
Okay.
In one of the previous classes, you mentioned that even if you normalize, we should not normalize our output. And
Yeah.
if we happen to normalize the output, then we will have to kind of, I think, renormalize. So I want you to just maybe elaborate on that. And then secondly, you mentioned that some algorithms uh, can run even without you adjusting for the missing values. So I wanted to ask, like, do those algorithms do those platforms do the imputation themselves, or they just ignore the missing values around the algorithm?
Okay. Thank you very much, brother, for that question. On your first question, yeah, we did mention before that when you do normalization, you see, normalization, because you are trying to, if it is not necessary, somebody should not do it, by the way. You do it if it becomes necessary, because you are changing the data totally. As I've explained, the principle of normalization. You see, from 20 million, everything will be converted to between 0 and 1. They become very small, because sometimes it makes it easy for your algorithm to be able to generalize on them. And this is okay to do it if there is need for. But like I said, sometimes people can also have issue with it. Okay, when you normalize, you didn't let it work on the normal data, the actual data. That's why I said let the data speak. If the normal data don't work, then you can come back and do normalization. So normalization is one of the optional stuff you should do if it becomes necessary. Otherwise, if your algorithm is able to model your data without normalization, this is better. Now, even when you have to do normalization, then you try not to normalize your output. Yeah, thank you very much for remembering that. Because the output, you are going to use the output to compute the root mean square error. So if you normalize the output, you have changed everything to between 0 and 1, you get the point now. So by the time your root mean square error is going to come out, you're going to have lesser value because you are not dealing with the original value. See, so that is why every formula that deals with normalization, it's like a change of subject. So once you normalize your output before the modeling, so after the outputs are generated, then you need to denormalize the output generated, because you cannot compare normalized output with original data set, because the original data that is the original output is not normalized, that came from the client or that you actually gathered. So in that case, we cannot be comparing normalized data with not normalized output. So in that case, if you normalize your output, then you need to use the same formula to convert it to normal. And it's very simple. It's just change your formula. I think, remember, we discussed it that time. We can refer to our earlier videos on this. It's like saying for normalization, maybe this is the formula we use, x original one minus the new one divided by whatever formula. Just make your x here to be the new subject of formula, and then you can convert your target, the predicted result, to the normal value easily. However, we've noticed that by normalizing the input only, the features, without normalizing the output, you can actually improve your modeling performance. So personally, I don't normalize my output. I leave it originally. But you can play with the input. That is okay. Normalize the input. You don't need to denormalize later on. You don't need to denormalize your work thereafter. So I think that is on the first question. So, Mr. Osman, can you just remind me about your second question, please?
Okay, Doctor. It's about you said some platforms are run even with some missing values. So
okay. Thank you. Yeah, I remember. Thank you very much. Sorry for that. Yeah. Well, there are, like I said, there are platforms that we do missing value automatically. Like, for example, now if you use, there are some experiments you can do in Weka, even with a missing value, it does it. So there are, for example, decision tree has that some inbuilt, even feature selection are inbuilt in decision tree. Also, it has ability to take care of missing value without any issue. See, so some algorithm will work better, even work in weaker environment, for example. But in some programming environment like Python, you may not have that kind of flexibility, in which case I do say that missing value might be the most important pre-processing step that you need to do, because not all algorithms will allow you to run a data with missing value. So once you are done with missing value, any other one you can always ignore for the meantime and come back later to do it. So I hope that clarifies.
Yes, Doctor. Thank you very much.
You're welcome. So, Dr. Rashid, are you ready?
Yes, I am. I don't know if I'm audible now.
Yes, we can hear you.
You're
welcome.
Yeah, my question is still on this pre-processing.
Okay.
Pre-processing, yeah. I want to ask, if one work directly with the raw data and the accuracy is around 80% and the likes, does that suggest that probably one still need to be thinking of performance improvements?
Okay.
That probably, if there's need for performance improvements, that will necessitate now doing some pre-processing. And that's my question. And which I think is closely related to the second one. That who is it the researcher that will actually determine the satisfying performance? If, take for instance, 70% is satisfying to the researcher, and probably the reviewer might not be too satisfying, probably due to one reason or the other.
Okay.
Who will determine the satisfying performance?
Okay, thank you very much. So, yeah, it depends actually on what we are getting. So, as for the questions, the two questions are related, as you said. One, if you have 70%, it depends on the area. I remember there was an experience we had. We tried to emulate data from membrane technology. So actually, it was an initial stage of the experiments. So we started achieving, I think it was 70%, 68, 70%, or something like that. So we were still okay. There's starting an experiment and getting 70, that shows that you can push it to as high as possible later on. But the client immediately noticing this said, no, this is more than enough. That we have been using statistical method, we never reach 40. That 70 is super. You see, sometimes the people that owns the data set, and if it is you, so if it is some client, so they'll say, oh, this is enough. We can do more. They say, okay, we can do it later. And they actually took that, presented it, and they got it published. You see, this is depend on the user, the one who owns it, and what has been done in that area. But what they were known for is use of statistical methods. And they said 40, 50 was like a genius there. But now getting 70, and you are saying you are just starting. They couldn't wait any longer. They said, we report this one. Later, they are going to do on that. So the same way, so it's not that there's a particular value that is okay. If it is a data set that is just starting, and you are the first one to work in that area, you might be able to convince, after trying several procedures, and be able to convince that, okay, you have not even done feature selection, you are getting 80%, but this is the first area. And going out to show people that, oh, there's something in this area, oh, people are not even aware that they can even use machine learning in that area. You want to go to the research community to announce that, oh, there's an area that we can do work. In that case, 80% is not something bad. You publish even the idea that, oh, can we use this system here? So it's working. 80% for the start, that could be celebrated, actually. So it depends on the area also. You see, especially with the first user. Someone will say, okay, what a feature selection? Oh, this is the first time this is being done. I want to communicate it directly to, sometimes people communicate it in what they call newsletter. There's some journal, they have a special quick edition called newsletter. Or you have a totally new idea, you want people to quickly know about it, they publish it quickly. Because you want them to see that, oh, there's possibility in this area. Even though you are here to do feature selection, you see, you don't even check, maybe normalization will work for you. It's not compulsory. See, if your people appreciate it, that is it. Then the next stage of your work will be, okay, you now investigate. How can we take this even further? Can I do feature selection? Then can I try to normalize my data? Can I try to check maybe there's some outlier in the data set? You can see there are a lot of things that are not compulsory, but you must do before you actually move on with what you are doing. It depends on the area. However, if it is an area that has been highly investigated, lot of work are there in that area. Maybe your data set has been used before. Someone has gotten 95 or 90. You cannot report 80. No one will tell you to know that, oh yeah, you need to do more. In that case, you have to start trying several options that you need to try to get it better so that you can also at least beat what is available and also enhance how people can also know how to really deal with data modeling. I hope that clarified, Dr.
Alhamdulillah, it does.
Okay, Barakallah fi. So, I believe we have 4 more. Sorry. Usman Ismail, is it the previous raised hand, or can we go to, okay, Mutiula, you can unmute yourself.
Assalamu alaikum warahmatullahi wabarakatuh.
Wa alaikum salam wa rahmatullah.
Hello, sir.
You're welcome.
So please, I'm very sorry for asking this kind of question. I don't even understand anything, but I'm attending for the first time.
It's okay. That's okay. You're welcome. It's okay. You're welcome, Mr. Mutiula. So don't worry, you are going to understand. Everybody is welcome. So you start from a place. What I would suggest is please, we can mute our, maybe somebody is putting 2 machines. Okay. So one, I would suggest that you can chat with, I don't know if our admin is there, private chat, us to register your name in the WhatsApp group so that we can provide the guidelines for you. We have a WhatsApp group there where we do have we have a WhatsApp group and also Telegram group. You can see there, Dr. I think our admin is busy today, has an emergency to attend to. Dr. Tajuddin Mujisola, you can private chat him. Are you there, Dr. Tajuddin?
Yes, I'm here.
Okay, thank you very much. So, Mr. Mutiula, you can please private chat Dr. Mujisola Tajuddin. You will get your details. You send him your name and your phone number. They will add you to the WhatsApp group so that we'll post the starting videos that you need to watch. Okay, so you need to watch some videos that are kind of preliminary. So, and especially also, if you can, we will also recommend you to watch one seminar I presented recently, because it started from the beginning. It was made for College of Health. It started from the beginning for people who are just starting. I think those ones will be able to put you on the track. But be rest assured, it's not something difficult. It's okay. You can actually meet up easily. So as we go on. So you are highly welcome. And if you face any challenge, feel free to private chat us later so we can offer whatever possible assistance. So thank you for the attendance. And wish you all the best.
Jazakumullah khairan, sir.
Yeah, cool.
Thanks for the response, sir.
You are welcome. We have Mr. Ismail. Am I right? Ismail.
Okay. Assalamu alaikum, Prof.
Alaikum salam.
Good morning, sir.
Good morning.
Really appreciate all the effort you've been putting across in order to get us understood this machine language very well. I have questions and guidance.
Okay.
To the best of my understanding about the application of machine learning in information security, I find that very little work has been done in the area of the security of data in ISP, the Internet Service Provider. So now let's assume I want to apply the machine learning language for the security of the subscriber data in the ISP. I want to ask for the guidance to do that, number one. Then number two, I discovered that this ISP, they may not likely anonymize data set. So what can one make use of the raw data set to do that, even if it is available, which I don't know that it is available. So that is the guidance and the question I want to ask in regard of that. Thank you, sir.
Okay, thank you very much. You are welcome also for the participation and the question. Yes, in machine learning, like we always say, so let the data speak. The data actually will determine the possibility or otherwise. But one, we need to search critically in some of the very well-known research repository to see what has been done in this area. I know there are a lot of works are going on machine learning in data security, cyber security, and also for others. So if you're able to detect an area that is yet to be well covered, I believe that is a golden opportunity for you to also create something there and be one of the forerunner in that area. So wherever we can get data set, for sure machine learning can always be used, inshallah. And as for the anonymization of the data set, well, it's not compulsory that the data need to be anonymized. So if what they have, if they need to link it with the name or with the IP address, as the case may be, we know some things cannot be totally anonymized. So like, for example, we have the system where we need to predict the source of an attack. You see, you want to predict the source of a cyber attack. You need the IP address, you need some other stuff. You're able to do some training and then be able to predict if the attack is from within a country or outside the country. You know, this is a beginning. You want to predict if the attack is actually coming within the country or is coming from outside the country so that you know where to focus your attention on. It could also even be within states or interstate, as the case may be. So it is a possibility. So you have to check out how can you get the data set. This is the beginning. Once the data set is gotten, I believe it's a lot of possibility, even areas that people thought it was not possible to apply machine learning. A lot of works are already going on there. The data set gathering might be the initial challenge. And I want to suggest, if you're really interested in that area, you can private chat me later. We can see how we can provide better guidance for you so that we don't confuse people that are new in the forum as because of our time. So wish you all the best. Thank you.
Okay, sir. Okay. Thank you. Sir. I private chat you, sir.
You're welcome. Towards the end, Mr. Bakari Bolaji. Okay. Maybe Mr. Bakari, why is getting ready? Mr. Salami Hamzat.
Yeah, Assalamu alaikum, Prof.
Alaikum salatu wa barakatuh.
Yes, we appreciate your efforts.
Alhamdulillah.
Reward in abundance.
Amen.
Yes, my question is about normalization, sir.
Okay.
I've been thinking that normalization goes with regression modeling. Does it also go with classification modeling, sir? Does it go normalizations?
Okay.
That's where I want a clarification, sir.
Okay. Thank you for that. Thank you for that. I like that. That's a very good clarification. For sure, since there are two things we mentioned on normalization. We have the input. When I say the input, that is the features, the independent variables now, this time around. We're like X1, X2, X3. Then we have the target Y. For classification, we know our target is going to be yes or no. So there's no need to normalize this one. We don't normalize target for classification. You cannot even normalize it if you want to. The maximum you can have is 1 or 0. So there's no need to normalize it. So when you are talking of normalization for the target value, you can only do normalization for regression because it's the one that is going to have big numbers. However, for the input, which are the input variables, for both classification and regression, you can normalize the input. You know, we have X1, X2, X3. This can be the age, this can be the salary, and this can be other values and other features that are being used. Now, so like I was saying, that the features that have number, either for classification or regression, you can normalize them. It doesn't matter because, and in one of the clarifications I made earlier, you can have the same data set for two problem solution, multi-stage modeling. The same data set sent to me, I want to use it to predict if a student will pass or fail. That is classification. I want to know if the student will pass or fail. That is classification. You see? So the same data set I'm using. So then the same data I might decide to use it to predict what is going to be the actual mark that the student will score in the final exam, which is going to be regression. So either regression or classification, the input can always be normalized. Okay? It is only the target that we recommend that for regression, because you cannot normalize classification outputs. It is already 1 or 0, or yes or no. But for regression, which is actual value, this is the one we were talking about, that it should not be normalized as an advice. But if you want to normalize it, that is okay. But you must remember to denormalize the predicted value so that you can make it to compare with the original value that you have. So I hope that clarified.
Yeah, thank you, Prof. I really appreciate it. I appreciate the
welcome.
clarification. May Almighty Allah reward you in abundance, sir.
I mean, thank you very much. You're
Thank
welcome.
you very much, sir.
You're welcome. Mr. Olawi.
Assalamu alaikum, sir.
Alaikum salatu wa barakatuh.
Jazakumullah khairan, Prof.
Ayakum barakallahu feek.
Thank you very much, sir. My question is on if I'm having a benchmark paper that use a particular data set, and I think that I can improve on the results, for example, is it a must that I must reproduce the result using the same data set, or I should just go on with my own new method or model?
Okay, thank you very much. If I get your question, you say if you pick up, maybe you have a paper that has been published, you got a data set, you saw someone who has worked on that data set, and you want to see, oh, what is happening? What can I do? Can I make it better? Well, it's always good to want to reproduce what they have done earlier. I'll tell you some of the reasons, though not compulsory for you. They already say that this is what we have. We got in 80%, 90%. Okay, for you to start saying, okay, let me try to see if I can beat them. I want to come up with new ideas, new ensemble that no one used it before. It's okay. So you build it, you are able to beat them, and then you add some contribution, you are able to get some additional contribution that you can claim. That is all right. However, sometimes the need for reproducing the results actually may support you to know the direction you are going to take. Because when you that is one of the reasons why in the documented research paper you need to specify the experimental procedures and the upper parameter values you have used, and how you partition the data. This is actually how you determine if a paper is worth the honor of actually following up with it. Because some people out there, they are junks. See that you just need to ignore them. You cannot reproduce what they claim to get. They did not tell you how they partition the data. A lot of things are missing. So sometimes students do come to us with this kind of complaint. Doctor, this paper did not have any experimental setup. Even they didn't tell us how to partition the data. And I said, okay, send in the data from that. Send me that paper. That paper must have been published in a junk journal. I mean, where people just pay money and get it done without really doing any proofreading, I mean, any review properly. And it turns out to be this case. So in that case, you might get frustrated that someone is claiming to have gotten 99%, 98%, but you are struggling, even 92%, you struggle to be able to do it. You couldn't do that. So if you try to reproduce, you'll be able to know that, is it a word I can build on or I cannot build on? Or you better need to look for better results that have been presented out there that are more reliable. So, because sorry to say, sometimes we face this kind of challenges whereby what people claim so to have gotten is not as experimentally verifiable. So you could not target it to beat such, you would never be able to beat it. Imagine there was a case of a data set, very important area of prediction. It's a data set to predict the post-operative decision making. After surgery, after doctor might have spent several hours in the clinic operating a patient, then the doctor need to sit down to look at the data that were being collected during the surgery to take decision whether the patient should be sent to the ICU or sent home, or let him or her remain in the ward for some day or a day to recuperate. This is someone who's already tired, need to take this decision. The best is for him to always send everybody to ICU. However, ICU is having limited number of beds. You cannot always take that decision. Otherwise, you'll be in trouble with the organization it's working for. So this kind of system is very important. I want to help doctor to decide where should we send the patient that has just undergone a surgery to. That data was so imbalanced. Everybody working on that paper already got it 62%. They have tried. So the present researcher were able to get 70-something percent, 75%. But suddenly, towards the end of their research, they found that someone has gotten 98%. You see, they struggled to reproduce this 98. It was not possible. Then they started to write letter to get clarification from the author. How are you able to do it? Is there any assumption you made apart from what you wrote in your paper? No responses. You see, in this kind of case, then we have to trace who published this paper. Then we finally find out it's one of those junk outcomes where people just dump anything they want there and they call it journal papers. We need to be aware of this kind of scenario. We hope we don't fall into it. This is one of the reasons why it's always good to, first of all, try to reproduce the claim. If that's very, so you know that you are dealing with something that is real, because at the point in time, we have to ignore, that paper need to be ignored. It was not a valid claim that they made after our extensive findings. So to be sure that you are not working with this kind of scenario, this is why it's always good to, first of all, try to reproduce what they have done. Though not compulsory, but it's very good. So you know that you actually try to compare your work with a reasonable work where applicable. I hope that clarifies.
Jazakumullah khairan, sir. Thank you, sir.
Okay.
Thank you.
So I think the last thing there is Bolaji Bakari. Are you there now?
Assalamu alaikum, sir.
Alaikum salam.
Jazakallah khairan for sharing your knowledge.
You're welcome.
Yeah, my question is similar to the one you just answered now. You made mention of reproducing previous work in order to, compare it maybe your own work. So the challenge I am having in my own research is there's this particular work that has been done earlier in that same area. And I noticed that the person that actually worked in that area didn't put the data sets. So there was no way for me to actually reproduce to determine maybe whatever claim that he or she has made is actually right or wrong. So my own now is with the data set that I have now, after maybe going through all the necessary steps to carry out my own experiment. So how do I now confirm that okay, maybe the person said he achieved 67 or 90 something percent. So probably maybe I'm getting 90%. So how do I compare mine with the other person's work now, since I don't even have access to the data set to actually confirm that truly whatever has been done is actually the right result?
Okay, thank you very much, brother. So, yeah, like the question following the previous question you just answered. One, like I said, it's not compulsory to repeat. No matter how you try, you cannot repeat some. So, especially if they don't provide the platform. Some of them will not even provide the platform where they run the experiment. If it is in Python, it's in MATLAB, because machine learning is platform independent. You run it anywhere, I should be able to reproduce it anywhere. Because these algorithms are the same thing, with little margin of differences, as the case may be. So, but some that would not even tell you the partition ratio they use. To me, how such a paper got published is very strange. We usually trace such paper to have been published in, like I said, what they call the scamming journals. They just collect money from people and they dump it there. No review, nothing. So we try to avoid reviewing this and refining your work to this kind of work. You see, we try to avoid even comparing our work with them because it's not valid. See, we try to target top journals that will not allow any work to just be published anyhow. They will have gone through a lot of peer reviews process and make sure that the right thing has been done. As for the case you just cited, actually, there is no kind of basis for your comparison because it's using different data sets from the one you are actually using. You see, just for the sake of benchmarking in the environment, okay, so far on this area, work that has been done in this area, this is what they are able to achieve. You can cite it there for people to be aware, maybe in literature survey, okay, we did one earlier in one of our earlier presentations where we do mention that in this area, no one has been able to achieve this, although people work on other data sets, this was the level they were able to achieve. You see, they were not able to achieve what we achieved, although we are using different data sets. This is comparison just bypass. You don't compare data sets that different together. I mean, the outcome of different data sets cannot be compared directly, but we can mention it in past just for the sake of contextualization that in this area, so work can be done. This is what they have achieved. Although different data set, this is what we have achieved. So if you can reproduce what they have done, this totally different data set. There's no even need to waste much time on that. Since you don't have access to the data set, there's no way you can be able to say, is it correct or it's not correct? You just need to make a passing reference to it or to contextualize your work in that particular respect. You can mention whatever they have gotten. However, you cannot compare your work strictly with them because you are using different data sets. I hope that clarifies.
Yeah, yes, sir. Thank you very much, sir. Jazakallah khairan.
Well, yeah, Barakallahu Fik. So I believe that's the last questioner for the day, and that's why we're going to call it a day. So once again, wish you all the best, and as we always advise all, let us practice. Get your hands dirty, as they say, on examples, get data sets, trying to practice what we've learned. Machine learning is better practice or implemented through examples and also continuous practice so that you can become even better and understand how you can use it in your various daily endeavor. So thank you very much all for attending and wish you all the best. Thank you.